Okay, this is question 3 for HL, 4 for SL. So in a school, 70% of students do or play sport, 20% do theatre, 18% do neither. A student is selected at random. Find the probability that ... Okay, before I do the question or even read the question, I'm going to draw a Venn diagram. So I'm just going to do it up here, so I have enough space to do all these questions, but obviously you do it in the box provided. So here I have, let me do that again. This is sport, theatre. So I have sport, theatre, and I do want to put a box around the whole thing. Like this. So 70% to sport. Common mistake is to just put 0.7 there. You can't do that because you don't know if someone goes here as well. That has to be part of the 0.7. So I can't put 0.7 there. Similarly, I can't put 0.2 anywhere. But 18% do neither. I can put that into here. So 0.18 goes there. They do neither. Now, find the probability that the student plays a sport and does theatre. So they're asking us to find this as part of the first question, but to fill out my Venn diagram, I know I need to find that anyway. Now, how do I find that? Well, I want to look at combined events. Now, another very common mistake I see is that people see this, they go, the probability of A intersection B. So A and B both happening is the probability of A times the probability of B, and they just multiply them together. That's true only if they are independent events. That's why this is written here. For independent events, this works. But if it's not independent events, or if you don't know if it's independent events, we use this, combined events. It's the A union B is the probability of A plus the probability of B minus the probability of A intersection B. Okay, so let me write that out here. The probability of A union B is equal to the probability of A plus, in fact, hang on guys, I'm going to write that down here as part of my answer to A. So A is the probability of A union B is equal to, and actually why don't we go with S and T? So the probability of S union T is equal to the probability of S plus the probability of T minus the probability of S intersection T. This I know, union T, right? So union T is either of them happening. But I know 0.18 is neither do sport or theatre. So if 0.18% or 18% of students don't do sport or theatre, what percentage of students do at least one of them? Well, it's 1 minus this. So this has to be 0.82. Probability of S, sport, we have it, it's 0.7. Probability of theatre, we also have that, it's 0.2. And then this is the thing that I don't have, S intersection T. So I can just kind of, well, I just add this to the other side and I get probability of S intersection T, and then I'm going to subtract this from this side. So it's 0.7 plus 0.2, which is 0.9, minus 0.82 equals 0.08. So this now goes in here, 0.08. And once I have this, I can fill in the rest. So 70% do sport, so this has to be 0.62 because this plus this gives me 0.7. And this has to be 0.12 because this plus this gives me my 0.2. Find the probability that, part B, find the probability that the student does theatre but not sport. So theatre but not sport, it's that, it's 0.12. And if you have the Venn diagram drawn, you don't have to show any more working. So theatre but no sport, you can just write down 0.12, but it's theatre, if you just want to know how to write it, it's theatre and not sport. This is equal to 0.12. Okay, those two hopefully fairly straightforward. Second bit gets a little bit tricky. It says, at the school, 48% of students are girls and 25% of the students do theatre. A student is selected at random. Let G be the event that the student is a girl, and let T be the event that the student does theatre. Find G intersection T. Right. What I want to do here is draw a tree diagram. Okay, a tree diagram, because we're going to be going into consecutive events, or I'm going to see the probability that it's a girl and then the probability that they do theatre. So we're going to start here. We're going to have the probability that it's a girl. Oops, girl, boy. If it's a girl, theatre, not theatre. Now I don't know if I even need to fill that out yet. So let's just stick with this. Girl is the probability that the student is a girl is 0.48. Of the girls, 25%, 25% of the girls do theatre. So that's 0.25% of the girls do theatre. So that of the girls that don't do theatre, this has to be 0.75. Okay, so part C. I have this is my tree diagram done. I'm not going to fill out the rest just because it's focusing on girls and theatre. The probability of girls and theatre is, so this is the probability that it's a girl and they do theatre. Using our Venn diagram, it's just 0.48 times 0.25, which is, I don't even need my calculator because it's a quarter of 0.48, which is 0.12. Last question, part D. It says, determine if the events G and T are independent. Justify your answer. So if they are independent, so go back to this formula that I said, guys, here. If they're independent, the probability of A and B is equal to the probability of A times the probability of B. So let's write that. If independent, the probability of, it's the probability of girl, let me write this underneath. The probability that it's a girl and theatre is equal to the probability it's a girl times the probability that the student does theatre. Now, this is confusing because you've already done this. You've done the probability of a girl and theatre, and it's this times this. But this isn't the probability that a student taken at random does theatre. That's the percentage of girls that do theatre. So the probability of a student doing theatre is this. It's still the 0.2. So I'm going to find the probability of G times the probability of T is the probability it's a girl, which is 0.48, times the probability they do theatre, which is times 0.2, and this is equal to 0.48. Let me just do this with my calculator. I probably should know the answer to this, but let's just be safe. 0.48 times 0.2 is 0.096. That sounds correct. Yes, so it's 0.096, which is 0.096. Now, clearly, this 0.096 is not equal to this. So I'm going to say 0, because this is my justifying my answer. 0.096 is not equal to 0.12. Therefore, the probability of G times the probability of T is not equal to the probability of G intersection T, therefore not independent. So I've stated it at the end, but I've justified it here because I have shown that this formula is not satisfied or does not work. Okay, hopefully that makes sense, guys. I think the main kind of tricky bit to note is that this 0.25 is not the probability that a student does theater. It's the probability that a girl does theater, which is why I drew the tree diagram. Okay, I'll see you for the next question.